This video will cover the idea of event-controlled loops. In this video, we're going to review a little bit about event-controlled loops, which we've seen before, so that you'll be able to recognize examples of event-controlled loops and also write your own event-controlled loops. You probably remember that sometimes we don't know how many times we'll need to repeat a loop's actions. Maybe we want to keep going until the user gives us some indication that they're ready to stop entering input, or just until some event becomes true about the data that we're processing. And we call this style of loop an indefinite loop because the number of times that the statement repeats is unknown. We don't know how many times to repeat the loop just at the beginning. So a count-controlled loop in these situations isn't appropriate. And we talked about some examples last time about real-life situations that might be event-controlled. For example, shampoo directions, wash, rinse, repeat as needed. That's not a predictable number of repetitions. Also things that happen in games, like dealing cards until a player says stay in blackjack, or some other situation like that. Or playing games with dice where you maybe roll the dice until a particular value comes up on both die. You can't predict how many times those things are going to happen ahead of time, and so an event-controlled or indefinite loop is the best solution for those situations. Indefinite loops, you probably remember, are also written using the while loop syntax that we're already familiar with, and we went over the syntax for the indefinite while loops last time in class. Just like a count-controlled loop, you have to initialize some information before the loop starts, and that allows you to set up the loop control variable or variables so that they have the proper value before the loop begins executing. Then you include the loop condition. That's the expression that is set up so that the expression evaluates to true anytime you want to continue executing the body of the loop. But the expression becomes false anytime you want the body of the loop to stop executing. The entire body of the loop is the algorithm that you want to be repeated, and in Python, all of that is indented. After the loop terminates, you have the option of adding additional statements that would happen all the time, independent of whether the loop expression is true or false. These are only going to execute after your loop terminates. So when the expression becomes false, then you'll be able to continue on with these additional statements. Last week in class, we traced through an example program where we made a memory worksheet and also displayed the output from that program. We also talked about some common errors with while loops, forgetting to include the event update step, which creates an infinite loop where the program gets stuck inside the loop and can never escape it. So today we're trying out another example program, a program where we want to write some software that calculates the total distance for a trip. We're going to ask the user to enter the distance between two cities and to enter a negative distance when they want to quit repeating the process. Once the user enters the negative number, that means that we've got all the trip distances and that we can calculate the total. And then we'll print that out to the screen. So I'm going to switch over to Python so that we can write our software. So I have idle up. And I'm going to write our event-controlled loop. So we want to start out, and let's think about this. We need to have a loop control initialization step. We're also going to need to have a loop control step. That's where we write our while statement. And then we'll have our loop body, that'll all be indented. And then finally, anything that happens once the loop ends will go down here at the bottom. So let's think about what we need to initialize in this program. We're trying to keep going while the user enters a positive number as their trip distance. So we'll need to know what the first trip distance is before the loop starts. So I'm going to set up a variable distance and make that equal to, let's do floating point distances, just in case they happen to have a distance of like 2.5 miles. If you want to make an integer in your program, that's totally fine as well. And we'll prompt the user to enter some input. Please enter the distance between the 2 points. Super. And then I'm going to set up my loop control. That's where you write your while expression. And you want the expression to evaluate to true when you want the loop to continue. So in this case, we want the loop to continue as long as they don't enter something that's negative. So anytime the distance that they entered is greater than 0, we can make it equal to 0 too, that's fine. Then we want the loop to keep going. Oh, my Python's like real indented for this loop body. So then what do we want to do inside the loop? Well, we want to keep track of the total distance for the trip. So I'm going to make a new variable up here at the top and initialize that total distance. Set that equal to 0.0. As an initialization step. And then every time I get into the loop body, I want to add my new distance to the total distance. I'm going to say, update the value of my total distance, give it the value of the previous total distance plus my new distance. So that seems good. And then before I finish the loop, I need my update step. Where I update the value of the loop control variable. In my example, the loop control variable is called distance. So I want to read in a new distance value. I want to prompt the user to enter a new distance between 2 points or a -1 if they want to stop. Let's test out what the Python program does so far. I'm going to save it, and it's going to run. So it's asking me for the distance between the 2 points. So I'm going to say 2.5, and then asks me to enter another one. So let's say 3.5, and then it asks me again to enter a distance. So it's repeating. You can see how it keeps going until I give it the negative value. Let's put in a negative value next so that it'll stop looping. And indeed, the negative value made the program stop looping. Now note that it didn't actually calculate my total distance yet. It didn't print that out to the screen. We need to add that step into the program. But this was good for us to execute at this point so that we could ensure that the loop was working properly. We have the loop control set up well. So now we just need to add this final print statement that prints out the total distance after all of the distances have been read. So we've completed our loop, and now we just want to print out the final result. Total distance is total distance. That seems good. So now we have all of our steps in our program. We have our initialization step. That was where we set up the distance so that it had an initial value, a distance between 2 points. Then we also had to initialize a accumulator, something that would keep track of the total amount of data that was entered. So that was our total distance. We set that to 0. Then we added our loop control. That was where we told it when to keep going and when to stop. We want to keep going while the distance is bigger than or equal to 0 and stop if we enter a negative number. Inside the loop, the thing that we want to repeat is adding the new distance to the total and then prompting for the next distance. And then finally, after the user enters the negative value, we're going to come down here and print out the total distance that was entered. Let's test it out again. Let's try it with the same information. So that's 6 plus 7 should be 13 as my answer. And indeed, that's what it printed out. Total distance is 13. So that was just a quick example to help you know whether you are understanding how to create the event-controlled loops. Remember that every loop has 4 parts: the initialization step that happens before the loop, the condition or loop test, that's the Boolean expression that determines whether to keep repeating or whether to stop. The body of the loop contains all of the steps that you want to repeat, and those are always indented. And then the update step is the last step inside the loop body, where you modify the value or values of the loop control variables. And remember that all of the repetition statements that you need to write for this course can be written with a while loop syntax. Occasionally we'll use the for loop syntax just because it's more convenient with lists, but in general we'll be using the while loop syntax. It's the most important one to master.